Let's continue with question 29. So you have this equation. What is the unit of the equilibrium constant? So Kp equals to partial pressure of O2, partial pressure of NO to the power of 2 divided by partial pressure of NO2 to the power of 2. So here we are talking about ATM. So ATM to the power of 3 divided by ATM to the power of 2. So you cancel, it's going to be ATM. So the answer is going to be A. So 29, the answer is going to be A. Now let's move on. Okay, 30. So which statement describes the acid-base behavior? Okay, in this case, when I can see that this is going to be donating the proton. So this is going to be the acid. This is base. Okay, so this is conjugate acid, and this is going to be conjugate base. Okay, so let's see, we are HCO3, it's an acid. Okay, it's an acid, so this one is wrong. Okay, and the conjugate base for that, okay, is going to be CO3 2 minus. Okay, the answer is going to be A. Okay, let's move on. So section B, okay, so you have all these responses. Okay, so which statements are correct when referring to an isotope of a single element? So the isotope, okay, have different mass. Okay, the isotope do have different mass. They have also different nucleon number. Okay, but because they have the same number of electrons, okay, they have the same chemical reaction. Therefore, okay, the answer will be 1 and 2. The answer will be boy. Okay, next, which of the following molecule and ions have a regular trigonal planar shape? Okay, if you have AlCl3, okay, AlCl3, 3 bonding pair, yes, trigonal planar. CH3, okay, carbon, suppose they have 4 valence electron because it lost 1 electron, so CH3 alone, okay, so 3 bonding pair, trigonal planar. But ammonia, you should know, ammonia has 1 lone pair, so it's pyramidal. So the answer here also 1 and 2, so it's going to be also B. Yeah, next. 33. What are the assumptions of kinetic theory of gas, or hence the ideal gas equation? All collision of gas molecules are elastic. Okay, intermolecular forces are negligible. There is no intermolecular forces. The intermolecular distance are much more greater than the molecular size. Yes. Okay, so in this case 33, all of them, yeah, are going to be the assumption. Now, magnesium reacts with hydrochloric acid. Equation is given. Okay, all the details are given. So here, 1.21 sample, okay, reacts with excess, okay, to give you a certain number of moles of magnesium chloride. So let's actually calculate. 1.21, okay, magnesium is going to be 12. Okay, so roughly it's going to be, we are talking about, okay, 0.1, yeah, roughly about 0.1 mole. Okay, 0.1 mole, and then it's supposed to give you 0.1 mole of MgCl2, so therefore cannot, this is wrong. Yeah, so if you have 2.43, yeah, 2.43 divided by 12, okay, hold on, it's not 12. Yeah, 12 is the proton number, so 24.3 is actually the mass number. Hold on, yeah, let's actually do it again. MR, okay, let's AR, yeah, the AR. So here, okay, if you have 1.21, okay, so 24.3 is the mass. So if you look at, calculate 1.21 divided by 24.3, then it's going to be 0.05. Okay, 0.05 moles, 0.05 moles. They do react with 0.05 moles. So this one is correct. Okay, 2.43 divided by 24.43, that's going to be 0.1. Yeah, 0.1 mole. 0.1 mole, okay, for B, yes, 0.1 mole. Sample reacts completely with certain number of moles of HCl, so they must react with 0.1 over, they must actually react here 1 mole with 2, so they must react with 0.2 moles over here. So we need to actually tell that this is 0.2 moles. And when I see over here 100 times 1 is already divided by 1000, I don't think so, it's 0.2. So this one's wrong. So 4.86 sample, okay, 4.86 divided by 24.3. So we are talking about 0.2 moles, okay, 0.2 moles. 0.2 moles react with excess to give certain amount of hydrogen. So hydrogen, 1 mole, 0.2 moles of hydrogen, 0.2 moles. Every 1 mole, okay, occupies 24 dm cube. Okay, so 1 mole occupies 24 dm cube. So 0.2 times 0.2 times 24. 4.8 dm cube. So this is also wrong. So the answer is going to be only one, D. Okay, let us check. I think they say number 2 is correct. Okay, but let's check. Okay, 34. Okay, which statement is correct? Okay, so number 1 is correct. Okay, 2.43 sample reacts completely, okay, with a certain number of moles of hydrochloric acid. I think this one 100 times 1 divided by 1000, 0.1, 0.1, 0.1. No, because there are 2 moles over there. So this one definitely wrong. Yeah, definitely going to be wrong. So the answer is D. Yeah, 34 is D. Please change. Now, 35. In which pair do both species have the same number of unpaired electrons in p orbitals? Okay, so we need to actually write down. Yes, sulfur is going to be, sulfur is, okay, you need periodic table for this. Sulfur is 16. Sulfur is 16. So 1s2, 2s2, 2p6. It's already 10. 3s2, 3p4. 1, 1, 1. This. So which pair do have the same number of unpaired electrons in p orbitals? There are 2. Okay, Cl plus. So for Cl, 17, 287. 1s2, 2s2, 2p6, 3s2, 3p5. So if it's 3p5, 1, 2, 3, 4, 5, but after that is plus, so you need to actually remove that. So you can see the same number of unpaired electron there too. So yeah, 1 is correct. Br plus, okay, if you look at Br plus, similar, I think if you have Cl plus, Br plus, I think the same, okay, they will have this 2. And then In, okay, let's actually look at In. What is In? Indium, okay, indium is going to be group 13, yeah, group 13. So generally they follow like aluminium. Aluminium is 13. So 1s2, 2s2, 2p6, 3s2, 3p1. 3p1. If you get 1 more, then they will actually have 2. So for this one, it's going to be different, okay, than Br plus. So definitely wrong. Phosphorus, okay, if you look at phosphorus, that's going to be group 15. Okay, phosphorus group 15. And then we are looking at, okay, let's actually write down for 15, yeah. So 1s2, 2s2, 2p6. Okay, so it's already 10. So 3s2, 3p3. Okay, so 3 valence electron. So it means unpaired, 3 unpaired electron. And then Kr3 plus, Kr, they already have like something like your argon, okay, on your neon. Okay, if let's say argon is 18. Argon, if it is 18, 1s2, 2s2, 2p6, 3s2, 3p, okay, this is 10. If I put this one as going to be 6, this is going to be 18. Okay, so that's argon. So if you have, let's say, remove 3 electrons, if you remove 3 electrons from there, remove 1, 2, 3, you will get something similar. $35, the answer was A. This is correct. Number 3 is correct. So coming back to 2 again, Br plus. Br plus. Br plus is going to be something 2 electrons. In. In, you add 1 more electron. Okay, sorry. In is going to be, you add 1 more electron. So aluminium, where's aluminium? Aluminium, okay, 3p1, 3s2, 3p1. You add 1 more electron, you get 2. Yeah, 2 unpaired electron. Yeah, 2 unpaired electron, 2 unpaired electron. Yes, number 2 is correct. Okay, the answer is A. Okay, they say the number of unpaired electron. Okay, so this one is A. Okay, next question. Okay, this one, if you want to discuss further, I will discuss further. Yeah. Now 36. Okay, you have this methyl butanoate. Okay, ester. Which statement is correct about this methyl butanoate? So if you want to actually look at which one, so here it has no lone pair. It has lone pair. Okay, that's lone pair. It has lone pair. Okay, so this one is wrong. 15 sigma bond. Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. If I calculate, it's 16. So let's actually double check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. Okay, so one of the carbon atoms is sp2 hybridized. sp2, it means 3 bonds. Yeah, 3 bonds can be formed. So 3 bonds, yes, sp2. So answer is D. 36 is D. 37. Which allotropes of carbon has a giant molecular lattice? Okay, do remember Buckminster fullerene, they are not giant. Yeah, so diamond and graphene, yeah, they are giant molecular structure. So the answer is going to be, in this case, is going to be C. Okay, 2 and 3. Which statement is correct? The reaction is endothermic. Forward, yes. Okay, this is endothermic. Okay, so delta H is positive 20. Okay, so enthalpy change for the reverse reaction. Okay, so forward reaction is 20, so this is wrong. Enthalpy change for reverse reaction, if you look over here, then they lost, okay, 20. Okay, from here to here they lost 20, so negative 20, correct. So 1 and 2, the answer is boy. Sorry, this one activation energy, yeah, I'm wrong. Yeah, activation energy. Activation energy, yes, for the forward reaction is from the reactant all the way to the top. So 50 plus 20, 70. This is correct. So the answer is A. Okay, 39. So you have two processes, okay, and then we want to know which one is correct. H2S is a reducing agent in reaction 1. So reducing agent, normally they will reduce others, but in that process they get oxidized. Let's see whether they are oxidized or not. Okay, sulfur and sulfur over here. In this case, you can see that they lost hydrogen. Okay, if they are lost hydrogen, then they are oxidized. Okay, so this one is possible. So SO2 is reduced. Okay, SO2 is reduced. You can see SO2 lost oxygen, so they are reduced, correct? Hydrogen is oxidized in reaction 2. Hydrogen is oxidized. I think hydrogen is oxidized in reaction 2. I think should be H2S is going to be oxidized in reaction 2. Okay, I don't think so. That will be the best way to say. Okay, so the answer is going to be B. Okay, B. Which statement is correct in terms of Bronsted-Lowry theory of acid and base? Yeah. So water can act as acid and base. Yes, definitely true. Yeah. Hydroxonium ion are produced when ACl is dissolved in water. Yes. Okay. ACl plus H2O, they give you H3O plus Cl minus. So this is hydroxonium ion. The ammonium ion acts as a base, like a base, in the presence of sodium hydroxide. Sodium hydroxide, they donate. Ammonium ion acts like a base in the presence of sodium hydroxide. Normally, ammonia would react as a base with the presence of sodium hydroxide. Okay, because sodium hydroxide is already a base. So I don't think so the ammonium ion will act as a base. There won't be any reaction. Okay, unless we put it as ammonia. So in this case, I think the best answer will be as acid. Okay, ammonia will be as an acid, so they will give you an A ammonium. I don't think so. There is also an answer for this, but anyway, I don't think so. 3 is correct. So the answer is going to be B. Okay, done.